Here's section 6.3, factoring trinomials of the form ax squared plus bx plus c, and a is not equal to 1. So in other words, the leading coefficient is not going to be 1. Let's look at this first example and notice that the leading coefficient, the a, is not equal to 1. In this case, is 3. We're going to be using the same process we have done in the past. Using the x method, notice that the 16 is basically the b. Normally you would bring out the c, bring down the c and put it here, but it's not a 5 now. You have a 15, but how do we get the 15? We take the 5 and the 3 and multiply them, and that's how we get this number in the bottom. And then we basically look for two numbers that satisfy these two conditions, just like we have done in the past. What two numbers do that? 15 and 1. And then this is what we have done in the past. We just basically take these two numbers and write the following. But notice if you were to do that, if you were to write this, there's going to be a problem. If you were to FOIL this, it doesn't check. You don't get the original trinomial. So we have to do something else. We're still going to use the 15 and the 1, but now we're going to bring over the 3x squared and the 5 down, and this is where we plug in, this is where we use the 15 and the 1. And this I use the 15 and the 1. From here, now you have a polynomial, and there's 4 terms, and like we have done when we encounter polynomials with 4 terms, we use the process of grouping. So this is what we're going to be doing to factor this expression. So if you group the first 2 terms, I pull out the GCF, which is 3x. This is what I get. I do the same thing for the next group, and this is what I get. And then from here, what do they have in common? They have in common the x plus 5. So this is your answer. And it's very important that you actually check to see if this is correct. But if you were to FOIL, which I'm not going to, you're going to notice that it's going to give you the original trinomial that you were given to factor. Let's go to number 2. Same directions, different problem. We're going to use the x method. Negative 46 and then positive 88. So I'm looking for 2 numbers that satisfy that. This is negative 44 and negative 2. So then, again, I bring over the 11n squared and the 8, and this is where I use the negative 44 and the negative 2. And thus I have a polynomial with 4 terms. So this way I apply the process of grouping. I look at the first 2. What do they have in common? And 11n. So I pull it out, and this is what I get. And I look at the next group. What do they have in common? A negative 2, because the leading coefficient is negative. If you remember, we have done in the past. And then you end up with the following. These 2 are the same. So you factor one more time the GCF out of these 2 terms. And you end up with this. And if you were to take the time to actually FOIL this, you should get the original trinomial. Let's move on to number 3. Same process. The x method. Notice that I have a negative 180. It's a little bit larger number. It might take you a while to come up with the 2 numbers that satisfy those 2 conditions, but it's just a time-consuming process. Eventually you get to it, and with enough practice you'll get good at this. So the 2 numbers that satisfy that are negative 18 and 10. Bring down the 12c squared and the negative 15, and then you bring over the negative 18 and the 10. Then you have the following polynomial with 4 terms. You apply the process of grouping. You group the first 2. You pull out the GCF, which is 6z, and you end up with the following. Same thing. Common factor between these 2 is 5. So you pull out a positive 5. Now, one more time, you pull out the GCF out of these 2 terms. You end up with the following. This is the answer. FOIL, and it's your check. Let's go to the next slide. So here's number 4. Notice that now we have two variables, but we have done something like this on on a previous section, so nothing that we can handle. We'll still use the X method, 7 and 6, because the product of 3 and 2 is 6, and this is not too bad. We're working with 6 and 1. So then I bring down the first term, the last term of the trinomial, and this is where I include the 6 and the 1. This creating a polynomial with 4 terms. I'll apply the process of grouping. If I group the first two, what do they have in common? I pull out the GCF, which is 3x. I look at the next two, grouping again. I pull out a positive y. And again, one more time, you pull out the GCF out of these two terms, which turns out to be x plus 2y. You get the following. Take the time to FOIL, and it should check with the original trinomial. Let's go to 5. So again, you have to be very careful here, because notice that the leading coefficient is negative. So in addition to pulling out a number, you also want to pull out a negative. So the GCF, and notice that there's a common factor of 3, all the terms here. So you want to pull out a negative 3. Once you pull out a negative 3, notice the leading coefficient is positive. And then at this point, you're going to work with this trinomial. You're going to use the X method, 1 and then negative 30, two numbers that satisfy these two conditions, 6 and negative 5. And then at this point, I'm just going to ignore the negative 3 for a little bit, and I'm just going to focus with this trinomial, bring down the 6 and the negative 5. That's creating a polynomial with 4 terms. Then apply grouping. What's the GCF for the first group? What's the GCF for the second group? And this is what I get. From here, I notice that I need to pull out the GCF again, which is x plus 3. And this is my answer. Plus, I almost forgot, the negative 3. If you write this as your answer, this is the answer of the trinomial inside the parentheses, but we cannot forget about the negative 3. So now, this is my final answer. So here's number 6. Before I begin to factor number 6, I notice that they all have a common factor of 2. So I pull it out. Now, this is the trinomial in which I'm going to apply the X method. So I have 3 and then negative 18. Two numbers that satisfy those two conditions, the sum and the product. 6 and negative 3. Now I'm going to express this trinomial as a polynomial with 4 terms. So I can apply grouping. From here, I look at these first two terms and the next two terms. This is what I get. Notice that I'm ignoring the 2 for a bit. So once I'm here, I pull out the GCF of 3m plus 2m out of these two terms. This is what I get. And then I bring down the 2. And this is the answer. If you take the time to FOIL these two binomials, you should get what you see here. And the 2 matches the 2 here. Let's go to number 7. So we'll use the X method. Notice that I need to work with 5 and negative 50, two numbers that satisfy those two conditions, sum and product. We're looking at negative 5 and 10. Then I rewrite the trinomial as a polynomial with 4 terms. This is what we get. Factor by grouping. So if you look at the first two terms, we're looking at 25t minus 5t. You pull out the GCF, which is 5t. You look at the next group, you pull out a 2. This is what you get. So you continue with the process of grouping. Pull out the GCF of 5t minus 1. And this is your final answer. Next one. These are the last two problems. So here's 8. Before I begin factoring number 8, I notice that this is not in standard form. So I put it in standard form, and this is what I get. In addition to putting it in standard form, I also recognize that there's a GCF of 3. So I pull it out. Now I'm going to apply the X method on this trinomial. So we're going to be working with 13 and negative 48. Two numbers that satisfy that are 16 and negative 3. And then from here, I rewrite this trinomial as a polynomial with 4 terms, so I can apply the process of grouping. Same process you have seen in the previous examples. Group the first two, group the second two. This is what you get. Notice that I'm ignoring the 3 for a little bit. So once I look at this, they have 3n plus 8n in common, so I pull it out. This is what I get, and then I cannot forget about the 3. I bring it over, and this is my final answer. Foil these two binomials, and you should end up with what you see here. And it checks. Last one. Again, not in standard form. You put it in standard form. If you look closely, there's a common factor here. So you pull out the GCF out of all 3 terms, which is 6n squared. From here, this is where you can apply the X method. We're working with negative 7, negative 18. The two numbers that satisfy those two conditions, the sum and the product, are 2 and negative 9. I'm going to rewrite this trinomial as a polynomial with 4 terms, so I can apply the process of grouping to factor. Then group the first 2, group the next 2. This is what you get out of the first group, out of the second group. And notice that I'm not writing the 6n squared. But now that I pull out the 3n plus 1 out of these two terms, I bring down the 6n squared. And this is my final answer. And this actually, if you take the time to, again, FOIL this, you should end up with this trinomial. And this actually concludes the video.